we have this paper from October, November 2024, and we're going to do question number 6. So the first term of the convergent geometric progression is 10, and we have been given that the sum of the first 4 terms of the progression is p, so Sn is p, and the sum of the first 8 terms of the progression is q. Wait a minute, is q, and their ratio is 17 upon 16. Q upon p is 17 upon 16. Find two possible values of the sum of the infinity. Okay, so to find the sum to infinity, we need the value of r. Let's make our equations. So we are given this. So let's make our equation. So sum of terms, the formula to find the sum of the terms is given by a 1 minus rn 1 minus r. Okay, we are using this because we know that in convergent, or to find sum to infinite for the infinite progression, our ratio must be between -1 and 1. If it's not between it, then we are doing it wrong. First, we're gonna make equation for this. So p is equals to, our first term is 10, 1 minus, we don't know r, and n is 4 because you see 4. 1 minus r. Now let's make equation for this. Q equals to 10, 1 minus r at 1 minus r. Okay. Now we have been given the ratio. So what we can do is we can divide them. We can divide the both equations and we'll get our equation. So it goes like this. And what is q upon p? Q upon p is 17 upon 16. Okay. So if it is difficult for you to solve like that, you know what I do? Because I'm also a student, so it's kind of difficult for me to solve like that. It's really confusing. So I write it down like, okay, so if we multiply, so our this one equation will be reciprocal. Okay, so it's like this. Okay, are we doing it right? I think so. So this and this gets cancelled, and then we are left with. Okay, as you can see, something can be cancelled from here. So cancel 10. Cancel 10, and then we are left with, and then we can send it over here, and this send it over here. So it becomes 17 equals to 16, 1 minus r8. So let's do this, 17r minus 17r4, 16. Oops, it's just 1. Sorry. And it becomes 17, 16 minus 16, r8. So 17 minus 16. Okay, so it becomes 1 and minus 17r4 plus 16r8. So as you can see, we cannot solve these equations. Can you solve these kind of equations? I don't think we can solve these kind of equations. So what we're gonna do, we're gonna assume that r8 is equals to r square. So r4 will be c. What is the half of 8? It's 4. So r power 4 will be r. So we will solve our equation like this. Okay, we'll replace that. So let's r power 8 is r square, and r power 4 is r, and we're left with 1. So let's put this equation in our calculator and find the value of r. So we're getting our values, r is equals to 1, and the other one is r is equals to 1 upon 16. Which value are we gonna use? We can use, like, can we use this one? I don't think we can use this one because it is not between this. Okay, for infinite geometric progression, we need a ratio to be between them. What was r? R was power 4. So our equation is basically like this. So we have to take root 1 upon 2. So if we have root, so we are getting plus minus 1 upon 2. So this is our answer. R is plus minus 1 upon 2. Okay, so formula to find sum to infinity is a upon 1 minus r. So what is a is 10, and what was r? Here are two values of r. So 1 minus 1 upon 2, and then 1 minus 1 upon 2. Here we get two values of our sum to infinity. Let's put it in our calculator. And first value is 20. Second value is 20 upon 3. And in decimal, it becomes 6.66. Now let's see if we have done it correct. So as you can all see, we have done it correct. Thanks for watching.